In this tutorial, I will explain what OUI, OUI-36, AUI-64, DevEUI, AppEUI, and JoinEUI exactly are. This presentation can be found at this location. All my LoRaWAN tutorials and presentations can be found at this location. In this video, when V2 is mentioned, V2 refers to the Things Network, and when V3 is mentioned, V3 refers to the ThinkStack Community Edition. An organizationally unique identifier is a 24-bit number that uniquely identifies a vendor, manufacturer, or organization. The IEEE Standards Association Registration Authority assigns OUI values. See this link. Here is an OUI example with a 3-octet sequence. This is octet 0. By the way, octet means byte. This is octet 1, and this is octet 2. This OUI is registered to Cisco systems. Let's only focus on octet 0. This is octet 0 in bits. These 4 bits represents the hex value of F, and these 4 bits represents the value 4. The least and second least significant bits of octet 0 are designated the M bit and the X bit. The X bit is also called UL bit. The U refers to universal administered and the L refers to local administered. If the X bit is 0, then it is universal administered. If the X bit is 1, then it is local administered. The M bit is also called IG bit. The I refers to individual address and the G refers to group address. If the M bit is 0, then it is an individual address, and if the M bit is 1, then it is a group address. So in this example, it is a universal administered and it is an individual address. In octet 0, both the X and M bit have the value 0. The OUI-36 is a 36-bit 4.5 octet sequence. This is the first octet, the second octet, the third octet, the fourth octet, and a half octet. If we only look at octet 0, this is octet 0. The least and second least significant bits of octet 0 are again designated the M bit and the X bit. In this example, both M and X bit have the value 0. This particular OUI-36 is registered to the Things Network Foundation. An OUI-36 is created by the IEEE Registration Authority by concatenating 12 bits, these 12 bits, to a 24-bit IEEE-reserved based OUI after octet 2. So these 12 bits are added to this OUI. An assignee of an OUI-36, for example the Things Network Foundation, this OUI-36, shall not truncate the OUI-36 to use as an OUI because the IEEE Registration Authority will use the base OUI, this base OUI, to assign OUI-36 values to multiple organizations. As you can see, this is the base OUI, which is used to assign OUI-36 values to different organizations. So this OUI-36 is registered to the Things Network Foundation. This OUI-36 is registered to this company. This OUI-36 is registered to this company. And this OUI-36 is registered to this company. They all use the same base OUI, but they differ in the last 12 bits. The IEEE Registration Authority divides the addresses in 3 different size blocks. The MAC address block small, abbreviated MA-S. If a company is assigned this OUI-36, the company can assign additional 28 bits to create an AUI-64-bit address. This means a company can generate approximately 268 million AUI-64 addresses. This is a second address block size called MAC address block medium, abbreviated by MA-M. The company is assigned with 28 bits These 28 bits does not represent an OUI, it is just a 28 bits identifier. A company can assign additional 36 bits to create an AUI-64 bit address, which means the company can generate approximately 68 billion AUI-64 addresses. And this is the third address block size called MAC address block large, abbreviated by MA-L. The company is assigned this OUI, which is 24 bits long, which means the company can assign additional 40 bits to create an AUI-64 bits address. This means the company can generate approximately 1 trillion AUI-64 addresses. Companies or organizations can purchase a MAC address block with its own unique OUI, MAC address large, OUI-36, MAC address small, or 28 bits identifier, MAC address medium. As mentioned earlier, this OUI-36 is registered to the Things Network Foundation and is part of the MAC address block small. And this is an AUI-64 address. A company can use the purchased OUI-36 to create their own unique AUI-64 addresses for purposes where unique 64 bits are needed. In this example, the Things Network Foundation must assign additional 28 bits, aka extension identifier, to create an AUI-64 bit address. The Things Network Foundation can freely set these 28 bits. The previously shown AUI-64 address is an AppEUI generated by the Things Network console, version 2, as you can see over here. This part from 7 to D is the OUI-36. You can search the public IEEE Registration Authority master listings for the company names and addresses and which OUI, OUI-36 or unique 28 bits identifiers they are registered to. Navigate to this address and scroll down. Here you can download the MAC address block small, the MAC address block medium, and the MAC address block large. Let's open the MAC address block small and search for the Things Network. And as you can see, this is the Things Network Foundation, and this is its OUI-36 SEFTI B3D5 7ED. Alternative, use the Wireshark OUI lookup tool. Enter the OUI-36 value and press the button Find, and here you can find the results. Here are some examples. This OUI is assigned to Microchip Technology Incorporated and is part of the MAC address block large. This 28 bits identifier is assigned to Honeywell and is part of the MAC address block medium. And this OUI-36, which is assigned to the Things Network Foundation, which is part of the MAC address block small. The IEEE registration fees for the MAC address block small, medium, and large can be found at this location. If you want to own your own OUI-36, which is part of the MAC address block small, it will cost you $780. This contract fee is optional if you need a signed stamped hard copy of a contract, and this optional recurring fee is only needed if you don't want your company name and address to be displayed on the IEEE public listing. For more information about OUI and AUI, see this link. The Media Access Control Address, also known as MAC address, is a unique identifier assigned to a network card. These addresses identifies each node on a network. MAC addresses are primarily assigned by device manufacturers and are embedded in the hardware. Depending on the manufacturer, these MAC addresses can be changed. A MAC address includes a manufacturer's Organizational Unique Identifier, OUI, and an extension identifier, which can be set freely by the device manufacturer. A MAC address includes a manufacturer's Organizationally Unique Identifier, OUI, as you can see over here, and an extension identifier, which can be set freely by the device manufacturer. This OUI is registered to Apple Incorporated, and this is a 48-bit MAC address which belongs to a network card. The extended unique identifier is used to identify other devices and software. Just like a MAC address, an AUI address includes a manufacturer's Organizationally Unique Identifier, OUI or OUI-36, and an extension identifier, which can be freely set by the device manufacturer. As mentioned earlier, this OUI-36 is registered to the Things Network Foundation, and the Things Network version 2 generated this AppEUI, which is also an AUI-64 address. The whole point of an AUI address, same applies to MAC, is that they are guaranteed to be unique. If users start using random numbers to generate an AUI address, it is not going to be unique anymore. The self-generated AUI may clash with someone else's. As mentioned earlier, you can generate a local administered AUI-64 with a very low probability of collision. Here is a procedure to create a local administered AUI-64. Create a random 64-bit number. Here's an example. Make sure in octet 0, this octet, the X bit is set to 1 and the M bit is set to 0. Here's an example with an incorrect local administered AUI-64. If we look at octet 0, the X bit is set to 0 and the M bit is set to 1. This is not correct. The X bit should be set to 1 and the M bit should be 0. This is a correct local administered AUI-64. Again, the local administered AUI-64, the X bit should be set to 1 and the M bit should be set to 0. This means the N hex value should be 2 or 6 or A or E. Why? Because it ends with 10, 10, 10, and 10. The term provisioning a device means to evolve a device to a state in which it can be handed off to an end user for their specific use in a functional manner. In the LoRaWAN context, provisioning a device refers to storing essential data such as DevEUI, JoinEUI, AppKey, or network key on a LoRaWAN 1.1 device. Here's an example. The Things node, this node, is a LoRaWAN 1.0.x device. It is a waterproof matchbox size device with a movement, light, and temperature sensor. The device has an LED and a button. Out of the box, this device is provisioned with a DevEUI and AppEUI. In LoRaWAN 1.0.x, the following values are important: DevEUI, AppEUI, and AppKey. The DevEUI is an AUI-64 address that uniquely identifies the end device. The AppEUI is an AUI-64 address that uniquely identifies the entity able to process the join request frame. The purpose of the DevEUI and AppEUI are explained in detail in tutorial 21. The combination DevEUI and AppEUI should be unique, which means one or both these values must be unique. If your end device is provided with a DevEUI, you should use it. If your end device is not provided with a DevEUI, you should generate a local administered AUI-64, meaning the X bit should be set to 1 and the M bit should be set to 0. If your end device is provided with an AppEUI, you should use it. If your end device is not provided with an AppEUI, the ThinkStack Community Edition console recommends that you use an AppEUI consisting of all zeros. If you press this button, the AppEUI is set to all zeros, but only if your end device is not provided with an AppEUI. These are the three screens which you will see if you register an end device in the ThinkStack Community Edition console. Here is where you enter your AppEUI. Here is where you enter the device AUI, and in the last step is where you enter your app key. This applies for LoRaWAN 1.0.x. In LoRaWAN 1.1, the following values are important: DevEUI, JoinEUI, app key, and network key. The DevEUI is an AUI-64 address that uniquely identifies the end device. The JoinEUI is an AUI-64 address that uniquely identifies the join server that can assist in the processing of the join procedure and session keys derivation. The purpose of the DevEUI and JoinEUI are explained in detail in tutorial 55. If your end device is provided with a DevEUI, you should use it. If your end device is not provided with a DevEUI, you should generate a local administered EUI-64, meaning the X bit should be set to 1 and the M bit should be set to 0. If your end device is provided with a JoinEUI, you should use it. If your end device is not provided with a JoinEUI, the ThinkStack Community Edition console recommends that you use a JoinEUI consisting of all zeros. Ensure that you use the same JoinEUI in your device as you enter in the ThinkStack Community Edition console. If you press this button, the JoinEUI is set to all zeros. But only do this if your end device is not provided with a JoinEUI. These are the three screens which we'll see when you register an end device in the ThinkStack Community Edition for LoRaWAN 1.1. Here you enter your JoinEUI, your DevEUI, your app key, and network key. When registering a LoRaWAN 1.0.2 end device in the ThinkStack Community Edition console, the DevEUI and AppEUI are required. First, check if your device has the required AppEUI and DevEUI. Most commercially available end devices have these EUI numbers built in. If the end device has the DevEUI, use it. If the end device does not have the DevEUI, check if the ThinkStack Community Edition console provides a method to generate the required DevEUI. As of June 2021, this method does not exist. For the DevEUI, you can use your own local administered EUI-64. An online tool to generate your own local administered EUI can be found at this location. Navigate to this location, scroll down, press the Generate button, and this is the generated DevEUI, which is a local administered MAC address. If the end device has the AppEUI, use it. If the end device does not have the AppEUI, use an AppEUI with all zeros. Here's an example. You built your own LoRaWAN 1.0.2 device for a personal project using an Arduino Pro Mini, as you can see over here, as the microcontroller, with the Hope RF RFM95W as the RF transceiver module. The Hope RF RFM95W has no built-in DevEUI or AppEUI, which means the AppEUI is set to all zeros, and this DevEUI is a self-generated, local administered EUI-64 address. Thanks for watching. I hope you enjoyed the video. Please hit the like button and don't forget to subscribe. If you have questions, leave your comments below. I'll do my best to answer them.